Hey there everyone, today we will be going through this somewhat challenging volume question. So let's first begin by reading it. So we're told that a cylindrical train container is being filled with oil at a constant rate. After 30 minutes, the level of oil in the container rose by 1 meter. The container has a 3 meter radius, h meters in length. After another 30 minutes, the volume of oil reaches 100 meters cubed, work out h. Okay, great. So the best way to go about doing this question is to actually work backwards. So let's focus on two particular aspects of the question. So we're told that it is flowing at a constant rate. That just means that every hour there is a certain amount of oil being filled in, and it is fixed, it is constant, every hour is the same amount that is being filled. Great. The next part that we'll focus on is the fact that oil reaches 100 meters cubed after 1 hour. The reason why it's 1 hour is because we first fill the container with oil for 30 minutes, and then another 30 minutes passes, and in total that gives us 100 meters cubed of oil. Great, now we can work backwards essentially to think what we need to do. So we need to formulate an equation in terms of H that would give us the volume of oil that was filled after an hour in terms of H and make it equal to 100 meters cubed. And that's it, we can then solve for H. So let's do just that. So the first instinct is we need to find the volume that was filled after 30 minutes, right? When it rose by 1 meter. That's this pink shaded shape or pink shaded part of the cylinder. So in order to find the volume of this part, of the pink part, we need to draw a cross section of the cylinder, essentially a circle, and then draw two radii and a chord in between them. And this chord, or the area of the segment, essentially, that this chord contains is our oil level, right? So this is the pink part. Let me indicate it. So this here is our pink part, and we need to find the volume of it. In order to do that, we need to figure out the area of this part first, and then multiply it by h, right? Because if I get the area, I can multiply by h to get the total volume of this part of the cylinder. Okay, great, so let's do that. Firstly, we would need to figure out what this angle here is, because the way we find areas of segments is that we need to figure out the area of this triangle, then the area of this whole sector, right? And then subtract the triangle from the sector in order to find the remaining segment area. Okay, great. So let's do that. First, let's label our radii. So it's a 3 meter here, 3 meter here. Now, we are told that after 30 minutes, the level of oil in the container rose by 1 meter. We can safely say that this 1 meter was being counted from the bottom here. And a line straight up would indicate, so obviously the radius, this would be the radius, 3 meters, and then this part would be 1 meter. So to show that on our 2D circle, let's draw another radius. So this is the radius, 3 meters, and then part of it here, right? So this part, let me show it like this. This part here is 1 meter, right? So this is 1 meter, therefore this part is 2 meters. Great. Now we can work out our chord length. So the length of this line here, we can work it out using Pythagoras. So we do 3 squared minus 2 squared all square root. And that will give us this part because we formed a right angle triangle here, right? Doing that will give us, so 3 squared is 9, minus 2 squared, which is 4, so we get square root 5. Square root 5, we multiply by 2 to get the full length of this line, of this chord. So in total, the length of the chord, is equals to 2 root 5. Great, now we can use cosine rule in order to figure out our angle, unknown angle here. Let's call it angle A. So we figured out that this length is 2 root 5, let's label that. We know that cosine rule is a squared equals to b squared plus c squared minus 2bc cos a. So we substitute every part of it into this formula. So we get 2 root 5 squared is equals to 3 squared plus 3 squared minus 2 times 3 times 3 times cos A. And then to solve for a, all we have to do is move these to the other side by subtracting, and then divide everything by whatever this is. So let's do just that. So we write 2 root 5 squared minus 3 squared minus 3 squared over minus 2 times 3 is equals to cos A. So let me do that on my calculator. That equals to minus 1 over 9. And all we have to do is take an inverse cos of minus 1 over 9. So we do cos to the power of minus 1 of 1 minus 1 over 9 is equals to A. And A is roughly equal to 107.08818912049 degrees. Keep it on your calculator as answer so that we can use it and find the precise final answer. So we just figured out our angle A. Now all we have to do is to find the area of this triangle and subtract it from the area of the segment. So the way we find the area of the segment is this angle A over 360 times pi r squared, which is our circle area. So r squared is just 9, right? 3 squared. And then we subtract from it the area of the triangle, which we'll find using the sine area rule. And it goes as follows. AB times sine C over 2. So 3 times 3 times sine the angle that we figured out over 2. And that should give us 3.93855075068, etc., etc. Keep it on your calculator's answer once again so that we can get a precise answer in the end. Never round up too early because you might end up with a slightly different answer than what you should have ended up with. So let's carry on with that. All we have to do now is to multiply this by h to get our volume, right? So we multiply it by h, so it means volume of the pink part is equals to 3.99, etc. times h. Okay, great. Now all we have to do is to multiply by 2, because this pink part, that is 1 meter, that was after 30 minutes. Let's now figure out after another 30 minutes, so that's 1 hour in total. So all we have to do is to multiply this by 2, because we know that the oil is flowing at a constant rate. So multiplying it by 2 should give us 7.877, etc., etc. Keep it on your calculator as answer once again. And finally, all we have to do is to equate this 7.8 ... times h to 100 meters cubed. So 7.877 ... h is equals to 100 meters cubed. All we have to do is to divide everything by 7.877 ... And so we get 100 over 7.87 ... which should equal to 12.695, which to one decimal place should equal to 12.7 meters. Kind of the horizontal length in here is 12.7 meters. And that's it. That's how you solve this question. I hope you enjoyed the video and I hope you found it useful. And if you did, please leave a like, comment down below, subscribe, and I'll see you in the next videos. Bye bye for now.